Okay, so I want to walk you through an example of creating the most parsimonious phylogenetic tree possible with our invented creatures lab. So I have my 5 invented creatures here, and you can take a look at them and start to really see what's similar, what's different. We've got some similar eyes, some are large, some are smaller. We have different eye shapes, different eye colors, and that's just the beginning, right? We have, like looks like a nova's evolved, and this little sideways mouth evolved at some point, and most of them have limbs. So you can really start to see those similarities. But how on earth, when you're dealing with these complex creatures that have gotten, 10, 15 new traits since their, most recent shared common ancestor with each other, how are you going to work it out? Well, here's the answer. You're going to make a list of traits, and from that list of traits, you're going to be able to quantify the differences between each of these creatures. So you can see my list here. I kept it pretty simple for, the sake of this lesson, and also just to show you that you don't have to go, crazy making these lists. Generally, patterns will emerge. So if you want, you can try making your own list. Since this is a video, you can pause it so we can flip back to the 5 creatures. You can pause, make your own list. And then just to show you, when you're done making that list, so I, did a lot of copying and pasting because I needed to be able to compare each individual to each other individual. And once I did that, I came up with this. So this is a nice, cool, it's almost like kind of a comparison tree. So you can see where they're compared with each other. There's nothing. And then you're quantifying the number of differences between each pair. And you can see I've circled the number 2 because that means there's very few differences between Phoebe and Rachel. So I'm going to put them on a branch together and go from there. After I find the smallest number, I typically look for the largest number. And, right now we're comparing different characteristics, but this could be quantified differences between nucleotides or differences between amino acids. So this is actually, the way some of the programs work on a much larger scale to generate phylogenetic trees. And so 11 and 10 are very large, so that's Ross versus Rachel and Chandler versus Joey. But when I look at Ross and Chandler, there's a small number. Okay, so I'm going to put Ross and Chandler together because they seem to be different from this other group with Rachel and perhaps Joey in it. So I'm going to put Ross and Chandler together. And I'm going to see if it makes sense to put Joey with Rachel and Phoebe. So if I look, Joey and Rachel is 5. Phoebe and Joey is 5. Okay, so that's kind of, the last place I needed to resolve on this tree was figuring out who Joey was more closely related to. And then I can connect the 2 major branches of the tree together and link them to their most recent but very distant common ancestor that they share together. And I can take this tree and I can just redraw it. You can use the squared off branches are very easy to draw. Now, using this amount of data, because again, I kept my number of characteristics pretty minimal, it's hard to say what the length of the branches should be, but that's okay. You can just, leave it kind of ambiguous. But since I made these invented creatures and I also, made the key and worked out the tree, I can tell you this is the correct branching pattern, but you can also see it in the pattern of the numbers. So pretty cool. There's other YouTube videos that I've got using molecular data for cytochrome C, so you can see the molecular data in action as well. Hope this helped. Can't wait to see the trees you come up with for your invented creatures.